Yeah, Sushant again. Let's start off. Did everyone try this infinite triangle? Or forgot? Forgot.
Sir,
Try. I'll give you a minute. Shaurya?
So will it go like at the centroid?
Go to the centroid. मतलब क्या होता है? Solve करो ना. What was this question? 19. Infinite grid was 20. This was 21. Chalo, everyone, cams on. There are a lot of people bunked the class. Cams on. How do you find this? Guys, you guys need to register in that Google form about Vimeo sent. Because based on how many people are coming, we have to tell the place there. Because we are going little early, he will be making some food sandwiches on based on number of people. So if you're not registering your name, Gulab Jam name milega. I'm telling you, you'll come there without eating desserts. You'll go back. You have to bring your own desserts from Swiggy. So do register so that we can get a count, because we have to tell them like how many people are coming. So accordingly, they'll be arranging the room. So don't forget, do register. Or else I had a new secretary, new staff, Bruce Lawrence, his name is. He will call you. Now अच्छा है ना?
He was last in pace, kya?
He used to be in pace.
Yes, I know him.
See, इतना famous name है, Bruce Lawrence. वो नाम ही ऐसा है. People will recognize. चलो. Get this. How do we handle this? We'll finish off with capacitors this Saturday. So we are going little slow because of your unit test, but next week onwards again we are back to flow. So do finish your backlog, whatever you have. We'll start with current electricity next week. We'll finish off current and then we will do waves. Only once the current and waves are done, major chunk of portion is done, like magnetism, EMI, SE, modern physics, done. The way it is going on, we should wrap up. Just before Diwali, we should finish off the portion. Then I'll give you a week break and then we'll start off with that revision program. How do we handle it? Can you see there's a symmetry here? If you see this line here, this nodes which are there, that is the main catch there. So your circuit actually becomes like this. What you can do, you can remove this nodes. So you can draw like this. So because of this, what will happen? Now, can you see clearly here? If this whole thing is X, isn't this branch also X? You have an infinite triangle inside a triangle, isn't it? If the whole thing was X, that is also X. So if I name these points as 1 and 2, so if CAB is equal to X, then C12 is also equal to X. Then your new circuit will become you can just replace this guy in the middle with an X. So C, and C, and that is X. Is this making sense? So you can just replace that entire inside thing with one single capacitor X. And this equivalent is what? Again, x, isn't it? So what is the C equivalent of this? CAB, this will be C and C by 2, x is in parallel. So C by 2 plus x, and this is C and C, this is bad, right? And C by 2 by C plus x, and that is parallel to plus C by 2. This is the equation. And this whole thing is equal to x again. So we get x is equal to multiply c square by 4 plus cx by 2 plus c square by 2 plus cx by 2, and this side will be by c plus x is equal to x. Let us quadratic solve this, you'll get x answer. I'll leave it to you. Please check the steps. So this has a bisector symmetry plus an infinitic grid, combination of two different things. Please look at this.
Sir, can you explain again? I had some internet problem.
Now I was saying if the whole thing was x, you can just replace this inside branch with x, right? So then this is how the circuit looks, no, Vrinda? So if you calculate the equivalent of this whole thing, that should be equal to what? X again. Right? Because the whole thing was x. If you find the value again, you should get x again. So from there you can find a finish it off. Please check. I'm not sure you'll get a good answer, but yeah. Easy. All got this thing? Chirayu, Anamay, clear? Labdi, got this? The infinite triangle? No, didn't get it? Joined late.
Yeah.
Last class homework problem, Tare. God, forgot. Nishita, got it? Kavish? Clear, na? Hasni, Rishi, got this? Great. Amu, got it, na? So, कितना आ रहा था? √3/2c क्या? I don't know, रे, actually. √3/2c. Anyone got it? We have one answer, √3/2c, it seems. I don't know. You can solve it quadratic, you will get it. Check. So if you see, right, circuits till now we did 4 different ways: series, parallel, Wheatstone bridge, nodal analysis, and symmetry. Symmetries is the most important one. Now the next one is Kirchhoff's law. So listen to this carefully. Quite a useful one. And like I said, it's the same idea which we will use in, again, current electricity. So let's see the Kirchhoff's law. So in a Kirchhoff's law, what we do exactly, we have two things here. Kirchhoff's junction law. Did we do the cube? Cube kiya na humne?
Yes, sir.
Yeah. Kirchhoff's junction law. What this thing says is the charge entering the node is equal to charge leaving the node. Simple thing. So basically, if you have something of this sort, if this is Q1, this is Q2, this is Q3. Wait, actually, we forgot one type of question, right? We forgot a model. I was thinking something is missing. Let's do that and then we'll go back to Kirchhoff's law. It's a standard model. Do you guys remember this? The Y shape. We did this in heat transfer. We did this thing in viscosity. Poiseuille's equation. So we have point A here, we have point B here, we have point C here. The potential is 3V, potential is 2V, and potential is V. And the capacitance are C, 2C, and 3C. This point is D. Find the potential at D. Wait. I think I have to teach you this Kirchhoff's law anyway. Let me finish all this. Actually, it is useful here. Let me teach this concept. So what is this junction law says is the charge incoming is equal to the charge outflow. So Q1 is equal to Q2 plus Q3. This is easy. Junction law. Whatever charge enters a node should come out of the node. Now, how to use this? Let's say if you have 3 capacitors. Actually, that comes after the junction law. I was thinking. So if you have 3 capacitors like this, let's say C1, C2, and C3. And let's say from here, charge is flowing Q1, Q2, and Q3. What is the relation between Q1, Q2, Q3? Q1 plus Q2 plus Q3 should be 0, right? The total charge coming out of a node should be how much? 0, because you can't get charge out of the node. Agreed? And then, and if you take the points here, let's say this potential is X, this potential is Y, this potential is Z, and this potential is some W. If you take 4 points like this, then you can simply write this thing as, so what is Q1? Q1 is a charge in this capacitor. So C1 into potential difference Vx minus Vy. Q2 is a charge in the second capacitor. C2 into potential difference Vx minus Vz. Q3 is a charge in the third capacitor, which is C3 into potential difference Vx minus Vw equal to 0. Please check how did I write this. Potential difference at D. Okay, that we will see. Are you getting this logic, everyone? What I did? From a node, the total charge flow is 0. Q1 plus Q2 plus Q3 is 0 because the charge cannot come out of the node. So what is Q1? Capacitor into potential difference. What is the potential difference? Vx minus Vy for this capacitor, Vx minus Vz for this capacitor, Vx minus Vw for this capacitor. Sure? This is the relation between the things. Understood? I think actually it is related to that. Get this thing. Find the potential at D. So we have 3 points here, A, B, C, and there's a point D in the middle. C, 2C, and 3C, find the potential at D. Ravish, you're saying D, V is the answer. Yeah? Let's see. Check karte. How do we do this? Let's see point. Yeah, C का potential is V. A का potential is 3V, B का potential is 2V, and C का potential is 5V by 3. Okay. We have one answer. Kavi says V, and we got 5V by 3. Two different answers. 5V by 3. Amu also got 5V by 3. So Kavish, please check your answers. Asthini got 5 by 3. Okay. So how do we do this thing? Let's say charge Q flows from here. So this will be Q1, this will be Q2. So what is the junction law here? Charge entering the node is Q, charge leaving the node is Q1 plus Q2. Agreed? What is Q equal to for capacitance? Q is equal to CV. What is V? V is the potential difference. Understand that. C is the potential, V is the potential difference, which is C into. So you're going from A to D. So you should take potential difference, initial minus final here, VA minus VD, because initial potential is more than final. That's why charge is going from A to D. Charge always goes from higher to lower potential. What is Q1? You're going from D to B, so 2C into VD minus VB plus 3C VD minus VC. Check. Do have a look at this form. Once you got this, C will cancel everywhere. VA will be 3V minus VD. This will be 2. VD, I don't know. VB is 2V. 3C and VD minus V. Open the bracket. So 3V minus VD, 2VD minus 4V, 3VD minus 3V. Bring all these to one side and these to this side. 3, 3, 6. So 10V, 6VD. VD will be 5V by 3. You're right. Do have a look at this. Yeah. All clear with this? Great. Let's see one more like that. This time this is grounded. Let's say this is 1 microfarad. This is 2 microfarad. And this is also 2 microfarad. This is grounded here. So this thing is 30 volt. And this is 10 volt. So this is grounded means 0. Find the charge on each capacitor. One microfarad, 2 microfarad, and volts are 10, 30, and 0. Kind of similar to the previous one. Find the charge on each capacitor. Everyone should try.
Sir, 420 at 32.
How do you proceed with this? Let's say.
So can you wait for a minute?
Everyone should try 428 32. Okay. Looks right. See, let's start with like this. Let this be X. Let's say this charge is Q1. Let this charge is Q2. Let this charge is Q3. So the signs will take care of it. You don't worry. Meaning this is Q1 charge, this is Q2 charge, and this is Q3 charge, isn't it? Means you're assuming these are positive plates. See what will happen. From junction law, we know Q1 plus Q2 plus Q3 is 0. The total charge from a node is always 0. You can't get any charge from a node. Whatever is coming, meaning in this now, one of them is actually negative. So what is Q1? Capacitance 2 microfarad into the potential difference, which is Vx minus 0. Q2 will be 2 microfarad, Vx minus 30 plus 1 microfarad, Vx minus 10 is 0. Microfarad symbol will cancel off. 2Vx minus 60 plus Vx minus 10 is 0. 5Vx is equal to 70. So Vx is equal to 14 volts. Yeah, 14. Once you got 14, you just need to substitute, right? So Q1 will be 2 microfarad into 14. So that is 28 microcoulombs. Q2 will be 2 microfarad into 14 minus 30 minus 16 minus 32 microcoulombs, meaning this is not the positive plate, this is the negative plate. Isn't it? You are assuming that's a positive plate, that's not a positive plate, that's a negative plate. Q3 will be 1 microfarad into Vx minus 10, so that is 4 volt, 4 microcoulombs. So these are the final distributions, everyone. This is how the system looks. This is 30 volt, this is 10 volt, meaning charge is actually flowing from here. How much? 32 coulombs. So this plate is positive, plus 32 coulombs. Then it came here, it got split this way. This side 28 went, and this side 4 went. This is the positive plate, and this is the positive plate. Is this making sense? So charge actually came from the 30 volt and it went to 0 and 10, which is kind of obvious. Clear how to find these distributions? Have a look at this. Ask me if you're confused. Clear? Next one. Any doubts on this? Anyone didn't get any step? Laddi, clear with this? Sure, no? Nanya? Clear with this? Anamai, Chirayu? Clear? Anamai, got it, no? Divyanshu? Sure, no? Dipanshu? If you see the online platform, right, heat and thermodynamics test is online. So what I'm doing now, every month, I'm putting 2 to 3 extra test papers for additional practice. Those test papers marks will not be counted, but it is for your additional practice, people who want to do a little more. But other than that, you have the regular papers are always there. So that tomorrow's test, right, is viscosity, surface tension, and elasticity. I know you didn't have enough questions in HCV and booklet, so I sent the assignments yesterday. So do have a look at them. Paper will be online tomorrow morning. So do make sure to give properties of matter, because the questions are not tough, but there are just too many different things. Next one, Kirchhoff's loop law. So first thing is the junction law, which is nothing but conservation of charge. So what Kirchhoff's loop law says is the sum of the potential differences across the elements in a closed loop is 0. If you actually think about it, you know what he's saying? If you start from one point and if you come to the same point, what is the potential difference?
0.
0, right? That's what he's saying. If you start at one point in a closed loop, you come back to the same point. Obviously, it is 0. But you can modify this into a bit and you can write it even like this. So potential difference between 2 points is sum of potential difference across the elements in any path between 2 points. What does it mean? Indirectly, what it is saying is if you're going from A to B, you take any path, the potential difference should be same, isn't it? If you're going from A to B, you go any path you take, the potential difference must be same. So example, let's say we have a circuit like this. So let's say this is V1, this is V2, this is V3, this is V4, V5, V6, V7. Don't worry what is that circle. Sir, it is any element. It could be a resistor, capacitor, battery, inductor, anything. So let's say if you take 2 points from here, A and B. So if you want to go from VA minus VB, you can go like this. So if you go in this path, what is the potential difference? V2 plus V3 plus V7. You can also go like this. V1 plus V5 plus V6. Or you can go like this. V2 plus V4 plus V6. It doesn't matter. You go from one point to another point in any path. I know plus minus aayega, sign convention, we'll see that. But if you go from one point to another point in any path, it doesn't matter, the difference will be same. It is a sum of the potential differences between the 2 points in any path. Is this making sense? So if you go from one point to another point, no matter which path you take, the potential difference should be same. All clear with this? Great. So how do we use this in the problem solver? Before that, we need to define a sign convention. Listen to this thing. Sign convention is a very important thing. You mess up one sign, the whole equation goes wrong. The sign convention, what it says, if you have a battery plus and a minus, and the voltage is V, if you go from left to right, the voltage will increase by plus V. So when you go from negative to positive, what will happen? Potential increase or decrease? increases, right? So plus V.
Increase.
If you go from plus to minus, potential will decrease, so minus V. So when we go from higher to lower potential drops. When we go from higher lower, potential drops. Same way, if you have a capacitor, let's say this is the positive plate and this is the negative plate, meaning charge is flowing like this. Now you tell me, if I go from left to right, you're going from where to where? Positive to negative plate. What is the potential difference of a capacitor? What is V equal to? Q by C, no? So if you go from left to right, the potential will drop minus Q by C. Agreed? If you go from right to left, you'll get plus Q by C. Are you sure? So example, let's say this is 2-volt battery, and let's say this is a 3 microcoulomb, and let's say this is plus 3 microcoulomb. And this is a positive plate, the red line. And let's say this capacitance is 1 microfarad. This is A and this is B. Can you tell me the potential difference? What is VA minus VB? If you're going from A to B, can you tell me what is VA minus VB?
One volt.
See, VA minus VB. First, you're going where to where? You're going from here to here, right? You're going from where to where? Negative to positive. You're going from lower to higher potential. So it is plus 2 volt.
Fine.
Agreed. Then you're going from here to here. You're going from where to where? Negative to positive. So that will be plus Q by C, which is nothing but 2 plus Q is how much? 3 microcoulomb by 1 microfarad. Micro will cancel off. That will be 2 plus 3, which is 5 volt. Yes. Please check. So when you travel from A to B, first through the battery, look at one at a time. Look at the battery. Battery will push you by 2 volts. Then the capacitor going from negative to positive, so it will increase by plus Q by C. What is Q? Q is the charge on the inner surface of the positive plate. So don't see this thing. You can take the positive plate. All clear with this? Let me give you one more like this. You try this answer. Let's say we have a capacitor, we have a battery, we have capacitor. We have a battery like this. This is A, this is B, this is C. This guy is grounded. This is the positive plate, 2 microcoulomb, and this capacitor is a 2 microfarad. This is 3 volt ka battery. This thing is 8 microcoulomb, and the capacitance is a 2 microfarad. And this is a 5 volt ka battery. Find VC and VB. A is grounded, so A ka potential is 0. I hope you got the question. Same thing, previous one, but I just kept 2 more batteries and 2 capacitors. Find the potential at C and potential at B. Right. Got 2 minutes.
सर कैपेसिटर में तो कहीं से भी जाएंगे कुछ फर्क नहीं पड़ेगा
है पॉजिटिव नेगेटिव प्लेट फर्क पड़ेगा ना बट
हाँ
VC is 2 and VB is 3. Okay. So let's travel from A. So you want to travel from A. See, this is how you can do another way. Let's say I'll start from A, okay? I'm going from A towards C. Listen, this is another way to do this thing. You can say VA minus VC, or you can say like this also. I'll start from A. Then I'm going through a capacitor. I'm going from where to where? Positive to negative plate. So minus 2 microcoulomb by 2 microfarad. Then you're going through the battery plus 3 volt. Where did you reach? C, na? You're getting it? You reach C. So VA is how much? 0. Wait, I think I did something mistake here. Sum of the potential differences, right? So I wrote wrong, right? Sorry. This thing is not VA minus VB. This is final minus initial, no? That is wrong. Final minus initial is the sum of the potential differences. It's not initial minus final. The previous one I wrote it wrong. It's VB minus VA. Final minus initial is the sum of the potential differences. But this is how, see, I can write this way. This is better. Start from A. Then when you're going from A, you went through the capacitor. So it dropped by minus Q by C. Then you increased by 3V. Where did you reach? You reach C. What is Eka potential? 0. This is minus 1. This is plus 3V. This is VC. So VC is 2 volt. Now when I go from A to B, I'm starting from A. Actually, you can do from C also directly now. So go from C to B. So VC, you're traveling from VC. You went through a capacitor. You went from negative to positive plate. 8 microcoulomb by 2 microfarad. Then you went opposite to the battery, minus 5 volt. And where did you reach? You reached B. Isn't it? You are traveling from C to B. On the way, you got a capacitor. You went from negative to positive. So add it. Then you went through the battery opposite, so subtract it. So VC is 2. This is 4. And this is minus 5. So VB is 1 volt. Please check. Right, Hasni, you got that right. Harsh, you also got it right. Have a look at this, everyone.
Sir, so in the previous question, we can also do like this now.
Yes, sir. इसमें you can start VA plus 2 volt plus 3 by 1. You reached B.
Okay.
Same thing. Do have a look. But it's simple, right? If you go from positive to negative, potential increase or decrease, Damu? If you go from positive to negative, potential increase or decrease? Decreased, right? So minus. If you go from negative to positive, potential increase to plus. So when I'm going from A to C, I'm going from positive to negative. So potential should drop, no? So minus, it decreased. Then when I go through the battery, minus to plus. So it increased, so plus 3. Sure? All clear with the sign convention? Please check.
सर ड्यूरिंग C to B तब कैपेसिटेंस के लिए पॉजिटिव क्यों है?
अरे ये दिया ना रेड कलर प्लेट पॉजिटिव.
अच्छा रेड, अच्छा पॉजिटिव, ओके
The red color plates are positive.
ओके सर.
All got this? No. Now how to use this to solve circuits? Step to solve a circuit. Step 1. If there are more than one battery, if there is more than one battery, right? Choose any one battery. Let's say there are 3 batteries and you're confused from where the charge is coming. Doesn't matter. You start from anywhere. Choose any one battery, giving a charge Q. I'll give an example, don't worry. Choose one battery. Assume charge Q flowing out of it. So if there are 3 batteries, assume one guy is dominating and giving charge for everyone else. Second, use junction law and distribute the charges with appropriate symbols. Third, apply Kirchhoff loop law. Means you have to go in a complete loop. Loop meaning you have to come back to the same point. Apply Kirchhoff's loop law such that all elements are covered at least once. So if there are 3 batteries and 2 capacitors and 1 resistor or anything, you have to make sure you're going through all of them at least once. All elements are covered at least once. And solve the equations. Fourth, if you want to find C equivalent, assume battery B with charge Q. And find Q by V ratio. Find Q by V, which is nothing but C equivalent. Have a look at this. Let me show you one example how to approach, and then I think we'll do a few problems on this. Please read through the steps once. Clear? Let's see an example. Listen carefully. Let's say we have a capacitor like this. This is 2 volt, this is V, this is C, this is 2C, and this is C. Now, with whatever techniques I taught you till now, series, parallel, Wheatstone, symmetry, nodal analysis, कुछ कर सकते हैं क्या? Previous slide, have a look at this. Yeah. Now, how to do this thing? We can't do series parallel. We can't do symmetry. We can't do Wheatstone. Nothing you can do here. Look it out. So how do you start? Listen to the steps. Step 1. Step 1. Assume charge from any one battery. So I will assume charge Q flowing out of here. Agreed? Using junction law, split the charges. Now understand here. If the charge is flowing like this, whichever plate you touch first, that is a positive plate. The red plates are positive. You can ask me, sir, how do you know that is positive? I don't know. Assume it is positive. Science will take care of it. Then Q charge will flow from here. Let this charge be small q. Then the balance charge will be Q minus Q. This is a positive plate. And eventually again, this would be Q minus Q. This is Q. Q will come back to the battery. Remember, if you take Q from the battery, Q has to come back to the battery. This convention is clear. Next thing, Kirchhoff's loop law. Matlab you have to take a loop. I will take this loop here. I will take this loop here. 2 loops. I can start from anywhere. I will start from here for the right loop. So I'll start the right loop equation. See, you can start from any point, doesn't matter. Only terms will be thoda idhar udhar hoga. I'll start the right loop from here. Now see how it is happening. I can start from here in this corner. I'll start from here. First, what you're doing, you're going through the battery. How are you going? Negative to positive. So what should happen? Plus 2 volt. You're going from negative to positive, plus 2 volt. Then you're traveling like this. You're going through the capacitor. You're going from where to where? Positive to negative. So minus Q by 2C. Then you're traveling downward. Again, you're going from where to where? Positive to negative, minus Q by C. You came back to the same point. So I can write like this. Let this point be A. So this is VA plus 2V. You came back to A, isn't it? So VA will cancel now. So it's okay if you don't write it also. If you start from A, you go around and you come back to A. So this is your first equation. You get 2CV is equal to Q plus Q by 2. Now let's write for the left loop. Let's start from here. B. So I'm starting from B. So VB, I'm going through the battery. Now one thing, see, for a battery, it doesn't matter how the charge is flowing. For the battery, you have to see who is positive and who is negative terminal. If you're going this way, what is the potential? Plus V. Then look at here what you're doing. You're going this way. You are going from the negative to the positive plate. So potential will increase plus Q minus Q by C. Then you're going down the capacitor. You're going from positive to negative plate. Minus Q by C equal to, again you came back to B. VB will cancel. So we get CV is equal to Q minus Q minus Q. We get CV is equal to Q minus 2Q. So small q will be 2CV minus Q by 2. Take that and substitute here. So CV is equal to Q minus 2 small q will be 4CV minus Q. I goofed up somewhere. Yeah, I goofed up somewhere. This is minus CV. This is minus CV is Q minus 2Q to 4CV. Why am I getting 0 there? Get the equations right. 2V minus Q by 2C minus Q by C. वो right था. This is plus V plus Q minus Q by C minus Q by C. That is also right. So this
CV
is
is equal to Q by C आ रहा है.
this only, no? Small q is right only, right? Hare, what is saying, Rishi? This is CV plus Q. What is small q? Right only, right only. I'm just messing up some sign. So this will be CV minus 4CV minus 3CV. That is plus Q. 2Q हो जाएगा. So Q is equal to 3CV by 2. Check.
Sir, if we take the B point ऊपर थोड़ा मतलब
कुछ फर्क नहीं पड़ेगा.
Okay.
Then क्या करोगे? You'll go like this, ना? Means first this term will come, then this will come, then V यहाँ पे आएगा.
अच्छा, okay. But मतलब last में equate to VB करना पड़ेगा ना?
हाँ, VB तो वापस you have to come back to VB only, right?
हाँ.
Wherever you start, you have to come back. Please check this thing how I got this. Once I got this, small q का value will be 2CV minus 3 by 4, 4 to 8 minus 3, 5CV by 4. There, these are the charges. See, you can't solve this with series, parallel, Wheatstone, कुछ भी काम नहीं करेंगे. This is the only way to do. This is how you use Kirchhoff's law. Like I said, it's brute force. If you know your sign convention, you know the steps to solve, you'll be able to handle the problem. Have a look at this. The left one you took clockwise or anti. Left one actually I took this way. I took clockwise. You can take any direction, doesn't matter. It doesn't matter. You just multiply minus sign with the whole equation. All got this? I'll give one more like this. You guys try.
So, but if there's charge flowing from the दूसरा वाला battery, तो we have to do from that.
Oh, no, minus sign आएगा ना. You don't worry about that.
Okay.
Find the charge on the capacitors. Same thing, I just reverse the battery and change the number.
So can you show previous slide one? Yes, sir.
Now, just listen one thing, so that we'll all get the same equations. I'll just do something. Let's assume Q from the battery. Which battery you want to assume?
V.
यहाँ से assume करते हैं. V. Okay. So Q will go like this. So this is the positive plate. Q is coming here. Let's say this is small q. This is Q minus Q. We are doing this so that we all will get same equations. Write equation in this loop. Write equation in this loop. Now you do. Now we all will get same equations, or else actually you can choose whichever you want, but then we'll have unnecessary confusion. Get them. So solve and get the answers for capital and small. Try. Everyone should give it a try. Check your equations. See your equations, whether you got the same thing or not. I'll start from the left-hand side. I'll start from this point A here. So VA plus V minus Q by C minus Q by C. You came back to the same point VA. VA will cancel. We get CV is equal to 2Q minus Q. This is the equation 1. Now you can say, sir, I started from here. Doesn't matter. No matter where you start, equation to आना चाहिए. The right one. If you start from anywhere, doesn't matter. I'll start from here. I'll start from here. B. VB minus Q by 2C plus 3V plus you're going opposite to the negative to positive plate minus Q minus C is equal to 0. Sorry, is equal to VB. VB cancels off. You end up with 3CV is equal to plus Q by 2 minus of Q minus Q. That guy would be 3CV is 3 small q by 2 minus q. Check. So from here we'll get, so small q is 2q minus CV. Substitute here. 3CV is equal to 3q by 2. So that is 3q minus 3CV by 2 minus q. 6 2 6 plus 3 9 CV by 2 is 2q. Q is equal to 9 CV by 4. Got the same everyone? 9 CV by 4. 7, small q is 7 CV by 2. So small q will be 2q matlab 9 by 2 minus 1. Yeah, 7 CV by 2. Please check this thing. If you got the equation, it's just a matter of solving.
Sir, if we take that B below that 3 volt वाला battery, तो भी same ही आता.
Same आएगा, doesn't matter.
Sir, so at that time, what we charge you have to take from that 3V वाला battery?
Where? Which point? Are charge you're taking on whom, Ray? Gods. Charge you're
V
taking on the plate, not in the wire. कहाँ से बोल रहा हो? Charge B पे charge.
हाँ.
B पे charge क्यों होगा शौर्य? Charge is on the plate of a capacitor, ना रे? No? Sure? Confused.
No, sir, clear.
All got this? Everyone is getting how to write the equations. Laddi, getting this? Nishita? Let's see one more. V, 2V, 3V, C, C, and C. This is A and this is B. Find the charge on each capacitor in VA minus VB. Again, for our convenience, I will assume this is Q. This is small q, this is Q minus Q. Now you try. You can choose any loop you want. We'll just choose the lower loop and this loop, 2 loops. Get the equations and solve. Normally you can choose anything you want, but so that we will be in sync, I'm writing these things. Get the equations, get the equations.
Sir, so means while doing for मतलब sir last वाले question में एक plate के लिए हम जब करते तभी the ones we decide which are the positive ones, the other ones we take as negative.
Other one obviously other one negative हो जाएगा ना रे. एक positive है तो दूसरा negative है. ठीक है ना? See, Shaurya, it is like, sir, how do you know it is positive negative? Doesn't matter. आप choose करो. Okay. Whichever the charge touches, assume there's a positive plate, and then you start. Agar if it is negative, the science will take care of it. Okay?
Okay.
Get the equations, everyone. Dipanshu, are you getting these things? Try. minus 7 by 3V. See, let's say charge Q is flowing from here. Means this is the positive plate. This is small q, so this is the positive plate. This is Q minus Q. This is the positive plate. So we want this loop, and this loop. I'll start from A here. So the upper loop, VA, you're going through the battery plus 2V. Then you're going opposite to the negative to positive plate, so plus Q by C. Then Q minus Q by C minus V is equal to VA again. VA will cancel. You end up with V is equal to Q minus Q minus Q by C. So CV is Q minus 2 small q. This is equation 1. Did you get this? Why do we add a VB? Are you stopping here? It is just a path, right? You're just going through this. You're not stopping there. And second thing, does B is giving any battery? B battery nahi hai na? B is not a battery. B is not a capacitor. B is nothing. B is just a point which you named it randomly. Remember, potential difference will come only due to batteries and capacitors. Meaning, if that means if I call this point D, if I call this point D, why will you add everyone, right? The points don't make sense. Now we are going in the lower loop. Again, I'll go from VA. I'm going from down, so plus 3V minus Q by C minus Q by C minus 2 volt. I came back to VA. 3V minus V is CV is Q plus Q. If you solve both the equations, you end up with small q is equal to 0 and Q is equal to CV. Got this?
So means we take the loop of the upper part and then come back to again that loop.
You always have to come back to the same point. If you want, you can take a loop like this also. You can take anywhere loop, doesn't matter. Please check small q 0 aayega. Got small q 0? So next, what is the question? You want to go from A to B. So I'll go from BA. I'll go through the center line. Huh? I'm going from center line. VA plus 2 volt plus Q by C, you reached VB. So VA minus VB is minus 2 volt minus Q by C minus Q is 0. Minus 2 volt is the answer. Please check how to do this. Vrinda, are you getting the equations? Sure, no? Kavya? Divanshu, are you clear with this? Anamay, got this? Tanya? Chirayu? Rishita? Harsh? Clear? Ammu? So far clear? Great. Kavish? Clear? All getting how to use Kirchhoff's law? If you see, these are the circuits where you can't use any of the methods I taught you before. So Kirchhoff's law is the final weapon that you have. It will always work. Problem kya hai na? Brute force solving. There's nothing innovative about it. Take the charge, distribute the charge, write the equations and solve. And फिर भी you're getting only two equations. Later on, you will see you can get even 3 equations, 4 equations. It becomes quite messy. Clear? Let's see something little interesting. This is all just solving. Do check this page. Have a look at this. The equations, the sign convention, everything should be proper. You mess up one sign and the whole thing goes for a toss. Clear? Next one. Let's see how we'll do. Now in the exam, how they'll ask you something interesting. This they do ask you, but it is kind of little, yeah, brute force. Let's see if we have something like this. Find the charge on this capacitor. So this one, which is marked now, I just want charge on this thing. Remaining all capacitors are C. I can give you some value if you want. C is equal to 2 microfarad. Find the charge on that capacitor, which big alphabet C is there. How will you do this? Think. Exam, this is the kind of things you can expect. Now, one thing is sure, they're not expecting you to solve. इतना बड़ा circuit to solve नहीं होगा. कुछ तो है. Think I'll give you 2-3 minutes. Understand one thing. In JEE exam and BITS exam, right? They'll never give you a question which will take 4 to 5 minutes to solve. Because even the paper setter who's setting, he knows the time is limited. In a JEE mains, they will give you a question maximum 2.5 minutes. If the question takes more than 2.5 minutes to solve, matlab either your concepts are bad or maybe your solving speed is bad. Or maybe out of 25 questions in mains, there will be 3-4 questions which are exceptional, wo question hoga. But in a paper of 25 questions in mains, trust me, if you do the notes properly, you handle the weekend exams I'm conducting properly, right? You solve your basic material properly. Aram se out of 100, you'll score 70, 75 in mains. Aram se. How to do this? See, this kind of question, we have to use Kirchhoff's law. The problem is what? I don't know how the charge flows, but somehow, if you can find a path, listen to this thing. If you can find a path where you're passing through this capacitor and you're passing only through the batteries. Problem kab aayega? See, no matter whatever charge flows, if you go through the battery, it doesn't matter how much charge flows to the battery. It will matter only when the charge flows to the capacitor. So can you find a way through the capacitor where only you're passing through the batteries? Ever solved a maze? वो आता है ना हिंदी न्यूज़पेपर में पीछे maze जैसा. So now find a path from here till here where you should not touch any second capacitor. Find a path. Find a path such that in that entire loop, only this should be the only capacitor. You can have any number of batteries. Chalega. Think for a minute, then I'll show you.
Yes, sir.
मिल गया पाथ? Let's start from here. I'll come down this way, this way. I'll go through this. That is a path, no? See, you pass through only one capacitor. So if I write Kirchhoff's law, what will I write? 20 minus Q by C. You came back to the same point, isn't it? If you apply Kirchhoff's law in this loop, you will write 20 volt minus Q by C is equal to 0. So Q is equal to 20 C. C is given 2, so 40 microcoulombs. Got this? Huh, Laddi, clear with this? Everyone is getting this concept, right now? Sure. Now, this is not a capacitor question, but the current electricity one. Can you find this? Just find the path, okay? Solve nahi karenge. We want to find current in this branch. Means you should, this is okay, na? See, this is series parallel, right? I can solve this. I'll just simplify it, wait. I want you to find current in this branch. So find a path where you can pass through batteries, but they should only pass through this resistor. Just find a path. We will do this question in current electricity again, but I just want you to get used to that maze thing. Find a path. You are passing through this resistor R, and everyone else is a battery. Let's see. Did you find the path? See, I can start from here. I'll go like this, like this, like this. You can play like that. So if you want only this resistor, can you find a path for this guy? I want you to pass through only this resistor, the green one. You can go through any number of batteries. Main idea both are in this kind of questions, right? If you go through a battery, there's no problem. But if you go through another resistor or another capacitor, I don't know the charge and charge on that, so I can't solve. Find the path, find the path. Found it. Same the axle. If you listen, you have to go like this, here, like this, like this, like this. Clear? Like a maze. So you can play around with this question. I'll leave it there. But how to solve that actual question is solved later on. Clear. So Kirchhoff's law, let's see one more complex one. If you got this thing, I think your Kirchhoff's law is clear. Find C equivalent. This is not Wheatstone bridge. It's not balanced. 2C by C, C by 2C. It's not a Wheatstone, balanced Wheatstone bridge. You can't solve with anything that you know again. There is a kind of symmetry. I'll show you that.
So
So
diagonal
for our diagonal symmetry. But for convenience, what we will do, let's say charge Q is coming from the battery. Let's say this charges. So listen, I'll just give you the things. Just get me the equations. No need to simplify in this. Let's say this charge is Q1. So this is Q minus Q1. Let this be Q2. Then this will be Q minus Q1 minus Q2. And this will be Q1 plus Q2. Are you getting the charge flow? So there are three variables here. So this is one loop, this is one loop, and this is one loop. Get the equations. If you get the equation, job's done. Then I'll show you a simpler way to solve this, but let's get the equations. Equations, everyone. Let's see. See whether you got the same equations or not. I will write the left loop. So I'll start somewhere from here. I'll start from here. Let's call this A. So that would be I'm going down. So minus plus Q2 by C. This is plus Q2. Means this is the positive plate. This is the positive plate. This is the positive plate. This is the positive plate, and this is the positive plate. Plus Q by 2C. Again, you're going from negative to positive. Plus Q minus Q1 by C. Then you're going in the negative plate minus Q1 by 2C. Check. VA will cancel. The right loop minus Q1 plus Q2 by C minus Q minus Q1 minus Q2 by 2C. This is also plus minus Q2 by C is equal to 0. That's the right loop. The total loop through the battery V minus Q1 by 2C minus Q1 plus Q2 by C is equal to 0. 3 equations, 3 unknowns. If you solve, you'll get the answer. Have a look at this. This is how you normally do. 3 equations, 3 unknowns. This is using Kirchhoff's loop law. But you can actually solve this question using a junction law also. I'll teach you that also. You see which one you like. Junction law actually looks more easy. But this thing is more generalized. But do look at the equation. See where you messed up a minus sign, anything. Signs are important. You got the equations, it's just a matter of solving. And finally, you want to find C equivalent. Now you have to eliminate Q1 and Q2. You have to find Q by V. That ratio you need to find. Do look at the steps. Clear? How do you solve this question in a junction law? But actually here, kaisa hai na? Listen, there is one more symmetry here. You could have solved it in much easier way. Using a symmetry. This is called a point symmetry. 2C, C, C, 2C, and C. Meaning, if you see this and this are symmetrical, isn't it? Diagonal symmetry. So what is the meaning of this? If Q charge flows here, Q charge will flow here. If small q flows here, then small q will flow here. So if here q minus q flows here, means here q minus q should flow here. That means this is q minus 2q, no? Can you see you eliminated one variable? Previously you got q, q1, q2. यहाँ पे सिर्फ capital Q and small q. You reduced one equation. Look at the symmetry how I did. Because here it is 2C and 2C they should have same charge. C and C should have same charge. Diagonally the charge flow should be identical. So now you can write only two equations. This is one equation and this is one equation. This is a point symmetry or a diagonal symmetry. This is another kind of symmetry. It's a point symmetry along the diagonal. Clear? How to solve using this Kirchhoff's law. So listen to this alternate method. Can I turn the page? All clear with this? All got the equations? Amu?
Sir, why in the middle like q minus 2? मतलब
अरे ये q minus q ये small q तो balance जाना चाहिए ना यहाँ पे. Alternative using junction law. This looks more easy actually. The equations look more nice. So let's see. So the idea here is, see, this is battery V, 2C, C, C, 2C, and C. Now, what is the catch here? Since what we are interested is potential difference, it doesn't matter. I can start with anything. Let's assume this point is zero potential. Agreed? We can take anything. Let's assume this is zero. If this is zero, how much is this?
V.
V, right? So this point has zero potential. This point has V potential. Let this point be X and let this point be Y. Agreed? Now, if you look at the charge flow here, let's say from here, let the charge flow Q1, let the charge flow Q2, let the charge flow Q3. So if you apply junction law at X, what is the junction law? Q1 plus Q2 plus Q3 is 0. What is Q1? C into Vx minus 0. What is Q2? C into Vx minus Vy. I'll just write it as C into X minus 0 plus C into X minus Y plus 2C into X minus V. CC will cancel off everywhere. You get C X minus Y plus 2X minus 2V is 0. 4X minus Y is equal to 2 volt. Easy? Make sense? Now, if you apply the junction law at Y, so Y pe, I'll again do the same thing. Let this be Q2, Q1, Q3. You can ask, sir, how can you take same symbols? He cannot, don't take same symbols. Q2 dash, Q1 dash, Q3 dash. So what's the junction law? Q1 dash plus Q2 dash plus Q3 dash is 0. Simply any junction pay, total charge that is going out is 0. What is Q1 dash? Capacitance into Y minus 0. Q2 is capacitance Y minus X. Q3 capacitance Y minus V is 0. Simplify this. We get 2Y plus Y minus X plus Y minus V is 0. This guy would be 4Y minus X is equal to V. This is equation 2. Simple equations, right? From here, can you solve X and Y? Once you know X and Y, sub charges are given, right? So Q1, Q2, Q3, everything you will get. So which one is more convenient? Did you like this one, 3 equations, or this one? You see, junction law is a little more convenient if you see.
So I just had like a doubt in this, not the
No, no, no.
method, but like, how can we just assume 0?
Where
The
here?
potential,
Now, Rishi, end of the day, what are you interested in? The potential difference. So why does it matter? If you take this as 1, I'll take this as V plus 1.
Okay.
यहाँ पे देखा, end of the day, the potential difference से आएगा ना?
Potential difference, yes.
So it doesn't matter.
Okay.
No? You can take anything as reference, isn't it?
Okay.
It's like ऐसा सोचो ना. If I'm solving this problem, let's say block is mv.
Potential energy जैसा, yeah.
If I say find the speed when it reaches the ground, what do you do? So
Take
reference
reference as the ground.
yellow, doesn't matter. You take any reference. Loss in PE is gain in KE. Difference is what matters. And frankly speaking, there's nothing called zero potential. It is something which you define. All clear with this junction law? Have a look at this. This is one type of question. Now, the second type. These are good ones. The next ones we are doing, these are also important. Let's say we have a capacitor. We have a switch. This capacitance is C, this capacitance is 2C. On this capacitor, let's say this is a positive plate. We have charge plus Q, minus Q, and this is 0, empty. If you close the switch, find the charges on the capacitor and the heat produced. So you have one empty capacitor connected to a capacitor with charge Q. So this is uncharged. Find final charges and heat produced. Try for a minute, then I'll show you how to do this. Then we will see more. So if you connect a capacitor with charge Q to an empty capacitor 2C, how much charge will flow? Find the final charges and the heat produced. How
Q
do
by
we?
3.
Are?
Q by 3.
Listen, how to handle this. Let me show you one, then I'll give you one more like this. Idea is the same, huh? Like Kirchhoff's law only. This is how we do. Once you close this, let charge Q flow from the capacitor. So you just treat the capacitor like a battery. So let Q charge flow from here. So how much charge is remaining there?
Q minus.
Q minus Q. So this Q will come here. So on this plate, you'll have a charge Q. Again, the Q will go back to the capacitor. Are you getting it? End of the day, it is like a battery only. It will give you Q charge, it will go round and will come back there. Apply Kirchhoff's loop law. You're going from negative to positive plate. Red lines are the positive plates. Positive, negative, positive, negative. So if you're starting from here, you're going negative to positive. Let's call this A. So VA plus Q minus Q by C. Then you're going minus Q by 2C. You came back to VA. VA will cancel. You get Q minus Q by 2 is 0. So Q is equal to 2Q by 3. Means what are the final charges? Q by 3 minus Q by 3 for the capacitor C. 2Q by 3 and minus 2Q by 3 for capacitor 2C. What is the heat produced? Heat
Energy.
produced is initial energy plus work done by battery minus final energy. Here battery is not there. Initial energy is only one capacitor, Q square by 2C. Final energy will be Q by 3 whole square by 2C plus 2Q by 3 whole square by 2 times 2C. That's your heat produced. Please check.
Sir.
Hmm.
Sir, potential of both capacitors will be same.
Same, no? Wires तो
हाँ
same
सर,
है.
हाँ, V इक्वल टू सी क्यू करके Q माइनस एक्स कर दें दूसरे के लिए और दोनों को इक्वेट करेंगे तब भी सेम
आएगा रे गॉड आएगा. Next one ऐसा करके देखो. I'm teaching you a process for which is valid for all different models, ना? हाँ, what you're saying is right. Simply आप इतना बता सकते हो. This potential difference is equal to this potential difference. एक step में आएगा.
हाँ वही.
End of the day वही किया था हमने भी, but let's see the next one. I'm trying to teach you a more general method in case something changes, you know what to do. Divyanshu, who else got disconnected? Vrinda is gone. Divyanshu is gone. Can I turn the page? See. What if you have three capacitors like this? C, 2C, C, this capacitor has a charge plus Q minus Q. This capacitor has a charge minus 3Q plus 3Q. This is uncharged. Find the final charges. Again, what is the process? Assume any one capacitor as a battery, let Q charge go from the positive plate and distribute it. Apply Kirchhoff's law, you're done. Any number of places, it works. Try. How do you start? So I'll assume like this. Let Q charge flow from here. This will become Q minus Q, that's a positive plate. So if Q comes here, already how much is there on this plate? Minus 3Q. So abhi kitna ho jayega? Q minus 3Q. And remember, that's a positive plate. Whichever plate you touch first is a positive plate. You don't worry about plus minus, the signs will take care of it. Then charge Q is continuously flowing, so this is Q. Then charge Q again comes back to the capacitor. Is this distribution clear? So keep your sign convention pretty clear. Most people get confused with the signs only. Clear? Now apply Kirchhoff's law. I'll start from here. VA, you are going from negative to positive plate. So plus Q minus Q by C. Then you're going from positive to negative plate, Q minus 3Q by 2C minus Q by C. You came back to VA. C gets cancelled. Q minus Q minus Q minus 3Q by 2 minus Q is 0. This guy would be 5Q by 2 minus Q by 2 minus 5Q by 2. Means Q is equal to capital Q. Means what happened? This capacitor actually became 0. This guy became minus 2Q, this guy became 2Q, this guy became Q, and this guy became minus Q. Are you getting this? The top capacitor became completely empty. The uncharged became Q, and this 3Q became 2Q. Please check. All clear with this? Can I turn the page? Last one for the day. You took a capacitor, 2 microfarad, right? And you charged it to 100 volts. You took another capacitor, 3 microfarad. You charged it to 200 volts. Then you took these two capacitors and you connected in the reverse polarity. Plus, minus 2 microfarad, minus, plus 3 microfarad. Connected in reverse polarity. Find the new voltage. This in the previous one is same, but they'll ask you in terms of voltages. You connected the positive terminal to the negative terminal of 3 microfarad. What is the new potential difference across the capacitors? Finish off, last one. How do you handle this? How do you start this? First, you need to find the charge on the plates. What is the charge on this plate? Q is CV, right? And this will be plus 200 microcoulomb. This will be minus 200 microcoulomb. This will be plus 600 microcoulomb. This will be minus 600 microcoulomb. So basically you connected plus 200 minus 200. Reverse में you connected this guy to minus 600 plus 600. इतना clear? Charges दे दिया. Now what to do? Assume Q charge flows from here. Q goes here and Q comes back here. What will be the distribution then? I'll only show the positive plates. So how much charge is there on this plate now? 600 minus Q. How much is here now? Q minus 200. The potential difference must be same. Or you can apply Kirchhoff's law. 600 minus Q by 3 microfarad is equal to Q minus 200 by 2 microfarad. This is the potential difference, isn't it? The potential difference across the capacitors, both are in parallel, it should be same. So if you simplify this, you simply end up with 1200 minus 2Q is 3Q minus 600. 1800 by 5 is Q. The Q is equal to, how much is this? 36, 360. Got it?
Sir, in case if something is in series like this, so we have to use that Kirchhoff's one only.
हाँ यहाँ पे भी कर सकते हैं किर्चॉफ्स लॉ यूज करेंगे तो ये आएगा ना.
Okay.
So what is the potential difference here? 600 minus 360 by 3. This is coming out to be, how much is this?
80.
240 by 3, 80 volts. That is the potential difference. So 100, 200 सब cancel होके ये हो गया. Clear? Now for this thing, right, there's a shorter way. You can solve the problems much faster. Case 1, if you're adding, let's say C1 voltage V1, and if you're adding C2 voltage V2, plus minus, case 1, if you keep in same polarity, plus and plus, C1 V1 and C2 V2. Then we get the voltage V final will be C1 V1 plus C2 V2 by C1 plus C2. Case 2, plus minus plus, C1 V1 C2 V2, reverse polarity. V final will be C1 V1 minus C2 V2 by C1 plus C2. This will give the answer much faster. If you think about it logically, हम क्या कर रहे हैं पता है? Think about it logically. C1 C2 both are in parallel, right? Same potential difference. What is the C equivalent? C1 plus C2. If you keep it in same polarity, what is the total charge? C1 V1 plus C2 V2, no? Total charge by total capacitance is potential difference, right? If you keep it in reverse polarity, charge will subtract, right? Total charge by total capacitance. So comes in the exam, this will be faster to solve. You can solve it anyways, you know how to do. All clear with this? Check it out. So with that, we'll wrap up for the day. So next class will be directly on Saturday. Like I said, we shifted our class from Friday to Sunday, but this Sunday there'll be no class because we have an event going on. But anyway, we have UTs also. So this week, Saturday, we'll finish off capacitors. So you'll have enough things to do. So I know you have a lot of work, so it is okay. Next week, say we'll have as usual, like, Wednesday, Saturday, and Sundays. So, okay, so I'll see you on Saturday at 9 o'clock as usual. We'll continue from here. Only the last thing that is left is, we will do one more problem like this and we'll do a dielectric slabs. That's the last part in capacitors. With that, we'll wrap up the chapter. Okay, those are doubts, please stay back and ask. Also free to leave. So take care, stay safe. I'll see you on Saturday.